All right, we're back for the second part of OpenCL. OpenCL, because it runs everywhere, has to do a lot of querying. Now, it's kind of a pain to do this, but on the other hand, if you're using OpenCL because you want it to run everywhere, this is a good thing. Okay, so I'm going to show you how you go about querying it, and there's that program that was showed you at the beginning of the quarter called print info. Print info is basically written like this. When you want to find out what you've got on your system, yep, print info is your go-to program. But how does print info know? Here's how it knows. So the number of platforms um, really is sort of a vendor thing. We'll get to devices in a moment, but and usually you only have one platform, but you can query this. Now, there could be two function calls here. One that says, tell me how many platforms I have, and then the second one that says, now get me information on those platforms. And they decided not to do it that way. Okay, they decided to make it one function call for both things. And get used to this. This is prevalent throughout all of OpenCL. And if you take the Vulkan course, or if you've taken the Vulkan course, Vulkan adopted the same attitude. But here's how it works. Okay, so down here, let's go to the second call. Boom. We are going to fill an array of platform data. But before we do that, we have to allocate the platform data array of structures. And to do that, we need to know how many. So here's how you make that function call up here, number one, to find out. You basically tell it, no, 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 don't fill any arrays. I'll put a null in there. That means I don't have an array yet. Don't fill it. Just tell me how many I've got. We then take that and we use it here in the new call in order to create the array of structs. And now we make a second call to this saying, give me this number of platforms worth of information and put them in this array of structs. Okay, one call to get the number, then you allocate the memory, second call to get the information. Again, this is a recurring OpenCL pattern. How many, where to put them, how many total there are. And anytime you put a null in for where the function wants an address, it knows not to fill that. Okay, there are error codes. So these, you can see these return statuses. If status is not equal to CL success, print something about it failing. And that's a good thing too, because that tells you something about, like, maybe you don't have any graphics hardware. That is, we have some systems here at OSU that are compute only, and so if you do this there, you're going to get this function call failed because there's just simply no platforms there to return any information about, and there's not even a driver. Okay, these are the error codes, and CL success is a 0. All the others are negative. And so if you cared, you shouldn't, but if you cared, you could say if the status was 0, do nothing. Okay, otherwise, if it's negative, do something else. I wrote a function um, that will look at the status code and give you back a string to give you some hope in hell of figuring out what went wrong. And this is in the class announcements, that part about stuff you should all care about. It's up there. I really recommend you use it, because what you do is you pass the status in here. Here is a string. You can use it if you want. It's like if you might say, and this was called from my function AAA, and then this is where to send it. So this could be standard out, std err, something. Um, if you're writing to a file, and sometimes it's convenient to write to a file so it doesn't go whizzing by on your screen. But anyway, Yes, this is there. I really recommend you use it. Otherwise, you're just going to get a, oh, something didn't work. Okay, number of devices. This is the um, really the hardware. And for instance, just to give you a sense, if you've got an Intel-based system, you're likely to find two Intel devices, sort of an Intel platform and two Intel devices, because OpenCL will run on the CPU, the Intel CPU, and the Intel GPU. So that's sort of what devices are. And then if in that same system you've also got a discrete graphics card, you're going to get another platform and one device there. Again, you can see some examples of this. But anyway, same thing. Get device IDs. Tell me how many. uh, Allocate, and now get me those devices. So fill the data structure. Notice this thing here about CL device type all. I always set it to that, especially when I'm just querying the stupid system. What the heck have I got here? But you can limit it. Like you can say CL device type GPU, and it'll only list the GPUs that you've got. I prefer to list everything because in that device's array of structs, you can query what type it is. Is it a CPU device? Is it a GPU device? Okay. And so here's sort of how this works. And this is right out of print info is get the platform ID. Now loop through the number of platforms. Get the platform information, which is actually pretty useful, is you can get the name of the device or the platform, you can get the name of the vendor, you can get the version number, you can get some profile information. This is really useful. Now, to that platform, let's find out how many devices are on that platform. So we're passing in the ith platform data structure. And we're saying, give me all. And now we're going to loop through the number of devices that are on platform I, and we're going to ask device information, and we can find out what kind of type it is, meaning is it a CPU, is it a GPU? And just to make it easier, it doesn't just print out the type number, it turns that into, I'm a CPU, I'm a GPU, I'm an accelerator, because there are accelerators that will run OpenCL. It'll give you back the vendor ID, which in the print info I turn into the words Intel or NVIDIA. It'll tell you all kinds of stuff about the hardware. How many compute units does it have? What are the maximum number of work items you can have in each compute unit? Oh, look at that. It'll even tell you the clock frequency. So again, when you have a package like OpenCL that's trying to run on anything that you throw at it that has a OpenCL driver attached to it, yeah, there's all kinds of information. So if you've got just an NVIDIA card plugged in, here's what I got. This is off the system in my office, and I never bothered to enable the OpenCL drivers for the Intel CPU that's in it. So yeah, there's what you get. It's from NVIDIA. It's OpenCL, and it's a type GPU. You can also ask about extensions. And this is the way the Kronos group runs this. The Kronos group has got this horrible problem with all these vendors because some of them want to do extra stuff and the other vendors say, no, no, don't do that because we can't support that. And so the way they handle that is they allow vendors to put extensions. And so long before some feature becomes part of the official standard, it's an extension. And then other vendors can try it if they want or modify it if they want. This is how you go about finding out what extensions are available. In most systems, you get something that looks like this yeah, here's your device extensions. There are two you really care about. You care about them all, but there are two you really care about. Here's one of them, and this says that this OpenCL implementation is capable of sharing with OpenGL, meaning you can mix compute with graphics all in the same GPU. You care about that. When we talk about um, doing that in the OpenCL, OpenGL interoperability notes, you'll see why. The second one you probably care about is this one. That means that it has double precision. Okay, by default, OpenCL has to have single precision floating point, 32-bit. But this extension, if this extension exists, then that means that this device has 64-bit floating point double precision. And if you ever plan on using this sort of programming for scientific or engineering computing, you care because a lot of the simulations are so sensitive, chaos theory, the butterfly effect, that you really want double precision for that. So of all the extensions, these are the two you really care about. So that ends the second part of the OpenCL notes. That's how you query what you're actually running on so you can adapt to it and come back because we'll run some examples.